lines, rays, and angles. As we move into this new chapter, our focus on mathematics is changing from straight computation into geometry. This first lesson has lots of definitions. We need to pay careful attention to the different things we're learning so we can apply them over the next couple chapters. Let's have a look. We begin our study of geometry with a point. A point is an exact location in space. So points don't have length, they don't have height or width. They just exist. So any specific place in space is called a point. So if we highlighted this spot in space, we might label it point A. This spot in space might be called point B, point C, point D. And we would write it as point A. We usually use capital letters when we're dealing with points. So now that we know what points are, we can now define a line. Lines are a straight path of points that continues without end in opposite directions. So usually we think of point A and point B and notice how the line continues in opposite directions. So it goes this way and it goes that way. The arrows that we draw at the end of these segments here indicate that they will go on forever in a straight line. Okay, so this is line AB. Over here we have line CD. Here we have line QP. An interesting thing about naming lines is when we say line AB, we could also say line BA. Line CD over here could also be referred to as line DC. Line QP here could also be line PQ. So the order of the points that you name on the line does not matter when we're discussing lines. And the way that would show up is, again, if we had line AB here, we would write the A and the B next to each other, and we would put a small line over the top of it. So line AB is how this would be read. Or as I just explained, you can put the reverse the letters. So this could also be line BA. And we read it as line AB or line BA. So this is how we will write it in our problems. This is how we say it aloud. So we've learned points, we've learned lines. Now, if we take a look at a part of a line between 2 points, we will end up with a line segment. A line segment is part of a line between 2 endpoints. So we might have a line segment here, ST. Notice there are no arrows that indicate that this goes on forever. A line segment has a beginning and an end, or it might begin there and end there. Much like with lines, we can label this as line segment ST or line segment TS. Over here we have another line segment. We have an endpoint there and an endpoint there. So this would be line segment LM or line segment ML. So we read these as line segments on the first one, line segment ST, line segment TS. They're written like this. Notice it's an S and a T with just a bar over it, no arrows on the end. The order of the endpoints does not matter, but when we read it, we say line segment ST or line segment TS. So we've now done points, we've done lines, we've done line segments. There is another portion of a line that we are now going to discuss called a ray. A ray is part of a line that has one endpoint and continues forever in the opposite direction. So here we have an endpoint B, and it goes on forever through point C this way. So this is ray BC. And we would indicate that with BC, and then we draw a ray above it. Now, unlike lines and line segments, the order of the letters on a ray do matter. The first letter should always be the endpoint. So in this case, our endpoint was B. So the first letter when we write it is B. Okay? We could not call this ray CB, because if we begin at C and continue on in this direction, we'll never get to point B. So always begin with the endpoint. This is read ray BC. Over here we have another ray. It begins at U and travels forever through point V. So this would be ray UV. It is important to keep our rays consistent so we're not switching the letters around. It's one of the big things here in 4th grade. So now that we've learned what rays are, we can now move on to something called angles. These are angles, not angels. It's important to make sure it's LE, not EL. An angle is formed by two rays or line segments that have the same endpoint. So notice we have ray BA here and ray BC. The letter B is a common endpoint, and together this forms an angle. And the way we would write that is with this symbol here. That means angle, and we would read this as angle ABC. Notice angle ABC. Another way of naming this would be angle CBA. CBA. What you notice about both of these is that the middle letter B is this point here. We're going to call that the vertex. We'll be learning that here in just a moment, but that's the middle letter. So you could not name this angle, for instance, angle BCA, because the middle letter C is not the vertex. So angle ABC or angle CBA are fine. And sometimes, although I do not encourage it here in 4th grade, we refer to this angle as angle B. Sometimes you can label the angle by the vertex, but it gets complicated, particularly on the way this one's drawn, because we don't know if we're measuring the inside here or around this way, and we'll be getting to that very shortly. So 3 ways of naming this angle: angle ABC, angle CBA, or angle B. What about the second one? Here we have an angle that's made up of line segments that have the same endpoint. That would be point S. So we could call this angle RST, or angle TSR, or finally angle S. So we've done points, which have led us to lines. Once we had lines, we could see parts of lines, line segments. Also rays. When we put two rays together with a common endpoint, we form an angle, or two line segments together with the same endpoint, we form an angle. Just mention that the vertex is the shared endpoint of an angle. So ray KJ and ray KL have the same endpoint K. That forms this angle. And point K would be considered the vertex of the angle. Okay? And just so we know, the plural of vertex is vertices. Coming back to angles, we're now going to investigate many different kinds of angles. The first one is called a right angle. Right angles form square corners. So angles like this that form a square, or an angle like that forms a square, is called a right angle. We usually indicate right angles by drawing a little square in the corner. This tells us that that is a right angle. And to help us out in the future, we need to know that a right angle measures exactly 90 degrees. We'll be learning about degrees in the next chapter, but we want to get that down here now. So this angle measures 90 degrees. This angle measures 90 degrees. Even though I've drawn the line segments longer on this one than that one, the angle itself is the same measurement. And we'll see that again in the next chapter. The next angle we're going to discuss is called a straight angle. A straight angle forms a line. Now remember, we have a ray that would begin here and goes this way forever, and a ray that begins here, the same place, and goes the opposite direction forever. That creates a line, right? This looks just like the line that we started out with. Remember that lines do not have to just go horizontally on the page. They can go on an angle, they can go vertically, what have you. They measure exactly 180 degrees. And anybody who's ever skateboarded, if you turn the skateboard half a circle, that's 180 degrees. That's called a 180. That's why. Next, we have acute angles. Acute angles are angles that are less than a right angle. So this is smaller than the right angle that we just discussed. See, the space here is smaller than the space that we had here. This one as well, and this one as well. The way I like to refer to them is, think about a baby. We would say it was a cute little baby, right? Little tiny thing. So, acute angles measure less than 90 degrees. Okay? Acute angles are less than right angles. So if we have an angle that's less than a right angle, we probably will have an angle that is greater than a right angle. And that is called an obtuse angle. An obtuse angle is an angle that is greater than a right angle and less than a straight angle. Remember, a straight angle was 180 degrees. Okay, that is not an obtuse angle. That's a straight angle. It forms a line. So it has to be less than a line, but more than a right angle. So this is greater than a square angle. This is greater than a square angle. So right angles are smaller than obtuse angles, and obtuse angles are smaller than straight angles. 90 degrees for a right angle is less than any measurement for an obtuse angle, and that'll be less than 180 degrees. And while the book does not really get into this, we should learn what this angle is. This is called a reflex angle. A reflex angle is greater than a straight angle and less than a circle. So we had straight angles that are straight lines, okay? So these angles are going to measure more than 180 degrees. So a moment ago, I showed you an angle that kind of looked like that, and we said it was an obtuse angle. And that's because we were looking at the measurement here. But there's another measurement here. And if you look at this, this is greater than a right angle, or greater than a straight angle. A straight angle would be going like this, and this ray is even greater than that. So this is more than 180 degrees, but less than a circle. And a circle measures 360 degrees. And we call this a reflex angle. And because of that, it is important that we draw these arrows to show what part of the angle we are actually measuring so we do not get confused. That's a reflex angle. Now that we have all this information, let's take a look at something and see if we can apply it. Here is a drawing of certainly some lines, okay, and some other lines here with various points. So let's see if we can figure out what some of these things are. Can we identify a ray in this diagram? Well, there's several rays. We started here at point R. If that's the end point and we traveled this way, we could have ray RP. If we traveled this way, we would have ray RC. If we traveled this way, we would have ray RQ. If we traveled this way, we could have ray RB or ray RA that continues forever. If we began here, we could have ray BK or ray BJ or ray BA or ray BR or ray BC. You see there's a lot of rays. So let's pick the first one we did, ray RP. So we would write the R and the P, R being the end point, so that has to come first, and then an arrow on top of it, ray RP. Let's find a line. Again, there's several lines here. We have line QP, or we could even say QR is a line. We could also call that PQ or PR, because the order doesn't matter on lines. We have line AC, line AB, line AR, and the inverse of those, CR, CB, CA. We have line JK, line JB, line KJ, line KB. Lots of lines. Let's just pick one. How about if we do line JK? So we have a J and a K, capitalized, and then we draw a line above those two letters. And we read that as line JK. What about a right angle? Well, we want to look for the symbol for a right angle, and that's this little square here. So we have angle PRC, or angle CRP, or angle R. But notice angle R gets a little tricky. This is why I caution not using just the vertex, because angle R is here, but angle R is also here, and it's also here, and it's also here. So we need to be careful. In this case, as we'll learn, I believe, in the next lesson, these will all be right angles. But for our purposes, how about if we say angle PRC? So the right angle would be angle PRC. What about an obtuse angle? Remember, obtuse angles are larger than 90 degrees. Well, here we have to look. None of these will be. These are all going to be right angles. We have angle JBR. That would be larger than a right angle. We have angle ABK. That would be larger than a right angle. And obviously, we could say RBJ or KBA. So angle JBR is an obtuse angle. What about a line segment? Well, a line segment is a part of a line between two endpoints. Line segment RC, line segment RQ, line segment RP, line segment RB, line segment AB, line segment JB, line segment BK. So there's lots of line segments here. Let's take line segment BK. So we write the B and the K, and the symbol for a line segment is just a bar across the top. A line has the arrows on both ends, and a ray has an arrow only on one end. And finally, how about an acute angle? An acute angle is a smaller angle than a right angle. Right angles form squares, so none of these will be it. We said angle JBR is an obtuse angle. We said angle ABK is an obtuse angle. But what about angle KBR? This angle right here. That is smaller than a right angle. So angle KBR. We'll also point out angle ABJ would also be an acute angle. Okay, so lots going on in this lesson. Lots of definitions that we want to secure in our minds as we go forward, because that will help us with the lessons as we go forward. We learned about lines. We learned about points. We learned about line segments, rays, angles, different kinds of angles, straight angles, right angles, acute angles, obtuse angles, reflex angles, and then we learned how to label them and name them. So a lot's going on in this lesson. Lines, rays, and angles.